So our bell ringer today says determine whether these given angles or sides represent corresponding angles and corresponding sides or neither. So if we're looking for corresponding angles, what do we want to make sure? They have the same number of?
Lines.
Yep, arcs or lines for both of these. So if we're looking at B, how many arcs does it have? One. If we're looking at H, how many arcs does it have? So do those match? Yep, so that means these are corresponding angles. So core angles. Next up, we have BD. How many lines does BD have? One. How many does HK have? 3. Do those match? Nope, so we say neither. After that, we're going to look at this one, and we're going to complete the congruency statement. So angle J is congruent to which angle? So how many arcs does angle J have? So it has 2, so it's going to be D because D also has 2. And then how many lines or tick marks does CB have? 3. And how many have, which one has 3 on the other one? KH or HK. Okay, and then the last part is identify all the congruent angles and all the congruent pairs and then write a congruency statement. I'm going to do that one up top. So this is going to be number 5. So we're going to write congruent angles or corresponding angles, core sides. So let's begin with angles. One arc, we have angle B, which is congruent to angle H. 2 arcs, angle D, which is congruent to angle J. And then angle C, which is congruent to angle K. I want to talk about our sides. So we're talking about congruent sides. So congruent sides, we're going to start with the 1 tick mark and then start with the 1 arc. So it's going to be BD, which is congruent to HJ. The next one up is going to be D what? C, which is congruent to JK. And then last but not least, CB is congruent to KH. Triangle congruency statement. We're going to read those angles straight down. So BDC is congruent to triangle HJK. Exactly right. Okay, so our first one here, we're going to be doing 5.2 today, proving triangles are congruent using side, 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 or side, angle, side postulates. So the first one we're learning about is side, side, side postulate. We abbreviate that SSS. If 3 sides of one triangle are congruent to 3 sides of a second triangle, then the 2 triangles are congruent. So yesterday, to show that 2 triangles were congruent, we had to do all the sides and all the angles. This cuts your work in half. You only have to show the sides. This one is side, angle, side. We abbreviate that SAS postulate. If 2 sides in the included angle are congruent in one triangle, or if 2 sides in the congruent angle, let's try that again, Jenkins. If 2 sides in the included angle in one triangle are congruent to 2 sides in the included angle of a different triangle, then the 2 triangles are going to be congruent. So what that's saying is if we have 2 sides and the angle directly between them, so that's the included angle. It's not going to be one off to the side. It's going to be right in between those. So we read it right between them, side, angle, side, angle, side. That's how we know that we're proving it this way. So now we don't need all 3 sides. We just need the included angle and 2 sides. So here, this is what we're doing today, a proof. Proof is a convincing argument that shows the statement is true, and these are the steps of how to write a proof. Your first step is going to be list the given information. So whatever's told in the problem or shown in a picture. We're going to use the information from the diagram. We're going to give a reason for each statement. Use given information, definitions, postulates, and theorems. So everything we've learned up to this semester is fair game. And then we're going to list the statements in order, so we number them. And then at the end, the last statement is always what we're trying to prove. We always write that last. So in example 1, is there enough information to show that these triangles are congruent? The first thing is what we did yesterday. Can you show all the sides and all of the angles are congruent? No, we don't have enough information to do that. So then we move on to our other 2. Do we have enough information to show that all of the sides are congruent? No. Do we have enough information to show that 2 sides are congruent and an included angle are congruent? No, right? So there's not enough info. Info we don't know about. Okay. So which other side do we know something about? Do we know something about?
X, W, and Z.
Oh, W, Y.
So which one do we know about, this side or these two sides?
That side.
W, Y.
So we know something about WY.
We do.
So WY is in our first triangle. So if this one wasn't here, WY is in our second triangle. Did the size change between the two triangles? Or did it stay the same size? So did this switch between the two lengths? Nope, it's still the same side. So we see it stayed the same. So we do know that this triangle has WY being congruent to itself. Do you guys remember what the name of that property is? I think it was Taylor and Jasmine. And wasn't one of the Natalies? Okay. And we said, I don't remember which one began, but I think it was Taylor. Taylor is as tall as Taylor. And that was this property. Do you remember what that property is called? Starts with an R. Reflexive. So WX, let's try it again. WY is congruent to WY by that reflexive. So we're going to go on to the second one, but you at least know that now. So on to B. Do we know that all of the sides and all of the angles are congruent?
Yeah.
Do we know anything about any of the angles? So nothing's given, so we don't know anything about it. Do we know something about all of the sides? We do. So we know this one here is congruent to this one here. We know this one here is congruent to this one here. What about that third side? It's the same. How do we know it's the same? It's in both triangles. So let's list these out. KH, I'm going to draw a line here so I keep them separate. KH is congruent to KL. HJ is congruent to LJ. And then that last property, we have KJ is congruent to KJ. And we know that because of the reflexive property. Reflexive prop. How did I know these two? Because they're given in our problem. Yep, we see it in there based on the sides, so they're given. So we would just write given. Given. Give me 1 second, hon. Do we have enough information to say that these two triangles are congruent?
Yeah.
We do. So we're going to begin here. Triangle KHJ is congruent to triangle KLJ. And did we know it because of side, 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 or side, angle, side? Side, 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 because we knew something about all of the sides. So when we read it, you see that you know something about all the sides? Side, side, side. Side, side, side. So let's start here. FE is congruent to PQ. Oh, PR. Nope. PR. Okay, and then we have HF, which is congruent to PQ or QP, either way. Okay. We also know something about an angle. Which angle do we know? F and P. So we knew the first one because it was given. How did we know the second one? It was given. How do we know the third one? Given. Okay, so we're going to look at this and we're going to ask those same questions. Do we know that all of the sides and all of the angles are congruent? Nope. Do we know that all of the sides are congruent? Nope. So that leaves us with our last one, side, angle, side. So we had to see if we have two congruent sides. We do. We have a congruent angle. We have to make sure that angle occurs between them. So when we read it, we see that we have one side, the angle directly between these two sides, and then the other side. So side, angle, side. Over here, we're going to test the same thing. Side, angle, side. So since it's the one directly between those two sides that are congruent, we can say that these two triangles are congruent. So we're going to list them out. Triangle F, E, H is congruent to triangle PRQ. And we knew that by SAS, side angle side. Over here, we're going to do the same thing, listing the ones we know. Let's start with RJ. It's congruent to MN, yep. And then we have HR. Congruent to, you said LN?
LM, the first one. Instead of
LN.
MN should be LM.
And then our last part here is the angle. Angle H is congruent to angle N. So do we know something about all the sides and all the angles? No. Do we know something about all the sides? No. Do we know something about two sides and an angle?
Yeah.
We do. We know something about it, but for it to be side angle side, what has to happen? It has to be directly between. Is this between the two sides?
No.
Nope. So we can't use it. It'd be side, side, angle, and that's not one we use. So we see over here, it's not between it either. Side, side, angle. So we have not enough information. We don't know about that included angle. So, no, not enough info about included angle or other side. Because we could have still find about that longer side there, HJ or MN, and that would have allowed us to see if that was going to be side, 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 but we don't have it. So every time you're doing a proof, it always begins the same way. You draw a line, you make a T-chart. On one side, you're going to write statements. On the other side, you write reasons. I give you a point for creating this table. Every time you do one, you're going to create this table. So then our first step after that, based on what we had on our list on the front page, is we're going to list the given information. So we know point 1 is going to be SQ is congruent to PM because it was given. That's 2 more points. Point number 2, so the second thing we're doing, is we know that angle SQM is congruent to angle PM. That's supposed to be a Q. Q. And that's because that was also given. So now we're going to look at the problem now that we've set it up. We said the things that we knew, so things given in the problem. We can look at the picture and see what else is happening. We know that this side is congruent to this side. We know that this angle is congruent to this angle. Do we know something about all the sides and all the angles? No. Do we know something about all of the sides? No. We know something about angles, so we want to see if we can use side, angle, side. So, do we have side, angle, side? Do we know anything about this side right here? What do we know about it? It's going to be the same. So we're going to say that QM is congruent to MQ. And how did we know that? So not given, because it's not in our statements up here. It wasn't in our original picture. We just used this property twice. Reflexive property. So we know it by the reflexive property, which tells us anything is congruent to itself. Okay, now that I know that, I now have side, angle, side, correct? So I can now say that my triangles are congruent. So the last step in every proof is always what it says here to prove. This statement here is always what you put last. So we're going to say that triangle QSM is congruent to triangle MPQ. And we know that by, which one did we use? Side, 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 or side, angle, side? Side, angle, side. So this whole problem would be worth 9 points. This one, we're given stuff, and we have a picture, but we have to add it in. So we have AC congruent to EC, so we're going to draw that in. AC congruent to EC. We're going to put a tick mark on each of those. Our second one is we have DC is congruent to BC. We're going to add that in. And last but not least, we have AE is perpendicular to DB. What does it mean to be perpendicular? Creates a 90-degree angle. So if that's perpendicular to each other, so DB is going to be perpendicular to AC, I'm going to put one right angle here. So that way I can show that it's perpendicular. So we're going to begin by making that same chart every time. Left-hand side, statements. Right-hand side, reasons. And we're going to start by giving what we know. So our first thing we know is AC is congruent to EC. How did we know that? It's given. 2 points. Okay. 2, we know that DC is congruent to BC. How did we know that? Given. 2 more points. Third, we know that AE is perpendicular to DB. How did we know that? Given. So right now you're up to a 7-point problem. So all we've done is list what we know and how we know it. So far everything's been given. So we're going to look at this picture and we're going to see what we can prove. Do we know anything about all the sides and all the angles? No. So we want to look and see if we know something about all the sides or if we know something about 2 sides and an angle. Which one do you think we're going to have better luck? Do you think we'll have better luck finding something about this side and this side? Or better luck finding something about this angle and this angle?
Yep.
So we have a better chance of finding the 2 angles because they're vertical angles. Which we could use that whole logic, and I'm okay if you want to. So there's 2 different ways to prove this. Taylor pointed out one way. I'm going to write them here. We'll do her way. I'm going to do it in blue. So here you have 4. She sees that angle DCE is congruent to angle BCA. And how did you know that, Taylor? Vertical angles. Which leaves us to number 5, telling us that our 2 triangles are congruent. ABC is congruent to triangle ECEDC. And how did you know that? Side angle side. So this point right here would be 11 points. You would have 1 point for each step, 1 point for the chart. I'm going to show you the other one. You don't necessarily have to write it down. But the alternative to that method, you would have written down here. We're going to pick up at statement number 4. You would have showed that the same angles here, DCE, are congruent to BCA. And we know that because definition of, let's try it again. Not that they're congruent, but they're right angles. So we know definition of bisector. Step 5 would then be showing that these are right angles. So this one here would be, right. Okay, so on this one we had the 2 methods. You can see the first one showing that it's vertical angles. We used step 4 and 5. Or you had the alternative method of showing that we had 2 right angles because the definition of perpendicular bisector, showing that those 2 angles are congruent because all right angles are congruent. And then the last step is the same. Triangles are congruent by side, angle, side.